One of the questions from the Rhine Papyrus that is set up and you set up for false position is x plus 1/5 x equals 21. So to do this question by false position will be pretty easy actually. You try x equals 5, meaning the denominator. This question usually says x plus x over 5. They say a number plus 1/5 of the same number is 21. But when you put 5 in, you get 5 plus 5 over 5. It's not 21, but it's 6. So 5 is like too small of an answer. So what you do is we need to adjust 5, but we first figure out by what factor is it off by. So on the side, I do 21 divided by 6. 21 divided by 6 is pretty easy because these two add up to 18. 6 plus 12, I need 3 more, which I can get very easily. So 20 divided by 16 is 3.5. That's the factor that my answer was off by, my guess was. So I just do 5 times 3.5, which is 1, 5, 2, 10. Half is 2.5. And those three things add up to 3.5. So these three things add up to 17.5, which is the answer. So that's a good one for false position. Let me show you. Sometimes they did this question a bit of a different way. And there are some really hard questions that they choose this method for. The idea is that it's like they factored out the x, and then they divide, just like with modern algebra, divide both sides. So our answer is going to be whatever 21 divided by 1 and 1/5 is. Unfortunately, this is actually a hard question to do with a division, but there are times maybe where this is easier. I'm not sure, but I know they choose to use this method and to practice this method in case they need it. Let's look at 21 divided by 1.5. It's hard. 21 divided by 1 and 1/5. You'd have to go 1, 1 1/5, double it, you get 2, but you can't write 2/5, you have to look at the 2 over n chart. We're nowhere near 21, so we have to double it again. 4. You could double 1/3 to 2/3, but 1/15 you need to get to the double the 2 over n chart. Double it again. This becomes 9 1/3. Doubling fractions that have even denominators is easy. Let me go one more. I'm trying to get to the target number of 21. I have 18. 1/3 becomes 2/3. 1/5 doubled is 1/3, 1/15. That third and 2/3 are going to eventually go together. And the 1/10. Oops, I realized here, this 1/30th becomes 1/15. So the 1/5 becomes 2/5, which is written this way, and the 1/15 becomes 2/15, which is written this way. And just to see where we are now, this thing becomes a 1, so that's 19. And 1/5 plus 1/10 plus 1/30th, they would have known that that's the same thing as 1/5. Oops, sorry, another small mistake here. This isn't 1/5 here, that's 1/15th. Because if you look at the 2 over n chart for 1/5, you'll see 1/3, 1/15th. I'll just say a little thing about these three fractions. It would have been really well known that 1/2 plus 1/3 plus 1/6 equals 1. 1/3 plus 1/6 is 2/6 plus 1/6 is 3/6. So if they knew that really well, then if they see something like 1/10 plus 1/15 plus 1/30, they'll recognize that it's just 2 3/6, but they're all multiplied by 5, so it'll be 1/5. So this whole thing turns into 19 and 1/5. Which is 1 4/5 away from 21. So I'll also grab this 1 here. Now I've got 17. And that's now, 16 and the 1 gives me 20 and basically 2/5. I'll write it that way for a moment, just even though they wouldn't write it that way. The main thing is that for 17, we're going to need 3/5 more. I'll move this up here now. Now, if I want to get 1/5, I can multiply this 1 1/5 by 5, and it would tell me what the denominator would be. It ends up being 1/6. So basically, I took 5 times this thing, and we saw this in the division video. If I want to know, like, what times 1 1/5 equals 1/5, if I multiply both sides by 5, and I multiply both sides by x, I get x is 5 times 1 1/5, which is 6. So that's 1/5. But I needed to get 3/5, so I double the 1/6 to become 1/3. That's the same thing as 2/5. I don't mind writing 2/5 here because I'm actually not. The idea is that these two things add together to become 3/5, which is the thing that I needed. So I've got the 17 so far. So now I need to also put in these. It's really these numbers that matter. The fact that this becomes 2/5. I don't need, just like over here, I didn't need to change this 2/5 into 1/3 plus 1/15. It really didn't matter for our purposes. It was just for the sake of figuring out how much more do I need. And same thing over here. If I need 3/5, and if this is 2/5, this 2/5 itself is not being used anywhere. It's the 1/3 that gets used. Well, 1/3 plus 1/6 is 1/2. So the answer is 17 and 1/2. Same answer as this, but yes, same answer as this. False position was a lot easier in this case. But there are a bunch of questions, namely Rhine Mathematical Papyrus, I think number 30 through 34, are all questions that they did this way with division. Sometimes they have questions where it's like 20, well, the question starts off as saying x plus 1/2 x plus 2/3 x plus 1/7 x equals, something else, make up a number. But essentially what they end up doing is dividing 10 by 1 plus 1/2 plus 2/3 plus 1/7, and that's because if you were to actually factor it out, you would be able to divide both sides by that. And the division could be quite cumbersome. You saw in the last video how we had a pretty big division happening in that one. Just to get it accurate, Rhine Papyrus question number 31 was trying to get it equal to 33. I said in the last video that they just did 33 divided by this. What I didn't tell you is that the question was not started as a division question. The question was started like this. Now, whether there's some way to use false position in this question, maybe if you put like 42, try x equals 42 and see where it is. Maybe that makes it easier. Maybe it makes it harder. But it's not how they chose to do it in the Rhine Papyrus question 31.